All right, so we're going to look at graphing linear functions. And the way it's going to look, since I am using the word function, is we're going to use the function notation. So it'll be f of x equal, let's say, 2x minus 3. So we have this linear function. Now remember, what does the notation f of x stand for? Y. So this means the same thing as y equals 2x minus 3. Okay? So if I graph this linear function using a t-table, so I plug in a value for x and determine what y is. So if x is, let's say, 2, what's my y value?
1.
So you'd say 2 times 2 is 4. 4 minus 3 is 1. All right, so then I would plot the point 2, 1. And so when I do that, I get this point here. And remember, to graph a line, you need how many points? 2. We normally use 3 just in case one of our points is incorrect, because they're all supposed to lie in the same line. They're supposed to be collinear. All right, give me another value for x. Huh? 4? So if x is 4, 2 times 4 is 8. 8 minus 3 is 5. So I plot the point 4, 5. And then I'm going to use a ruler and graph this. And so then I have this line. It looks like this. Okay? So this is the graph of the line of the function. F of x equals 2x. What was it? 2x minus 3? 2x minus 3. Now I'm going to go ahead and label the points I just found. So this point was 4, 5, and this point was 2, 1, right? Let's go ahead and do another point on this graph. So, but let's pick a negative number for x. So give me a negative number for x. Negative 5 is going to be outside of this coordinate plane. Negative 2. So if x is negative 2, what's negative 2 times 2? And a negative 4 and a negative 3 is? Negative 7. So I'm going to plot the point negative 2, negative 7, which is right here. Okay? That's a point negative 2, negative 7. All right, so I'm going to go ahead and find the slope of this line. Now remember, to find the slope of a line, you need how many points? You had that on the worksheet you turned in yesterday. How many points? 2. Because that's what you need for the slope formula, right? You need 2 points to use a slope formula. So the slope formula, remember, is y2 minus y1 over x2 minus x1. The order matters, right? So if you put y2 first, then you got to put x2 first, because the order matters. And so I'm going to go ahead and use the points 2, 1, and negative 2, negative 7, just to put some negative coordinates in there. So let's go ahead and find the slope of that line. It also helps if you label those points. Let's call this x1, y1. It's really pronounced x sub 1, y sub 1. So this is my first point. Then the x coordinate of my first point is 2, and the y coordinate of my first point is 1. Over here, if this is my second point, then negative 2 would be denoted as what variable? x2, and this would be y2. And basically all you do is just plug those values into your formula. So I get y2, which is what? Negative 7. It says subtract, right? It doesn't say add, it says what? Subtract. So negative 7 subtract y1. What's y1? 1. Divided by x2, which is negative 2, subtract x1, which is 2. What's a negative 7 and a negative 1? Okay, negative 8. And then what's a negative 2 and a negative 2? And so I get what slope? Positive 2. Okay? Now, I want you to look at the function y equals 2x minus 3, or f of x equals 2x minus 3. You found the slope to be what? 2. In your equation, do you see a 2? Yeah. It happens to be the coefficient of what letter? X. What's the constant right here? Negative 3. What do you notice about the graph that we just drew? It crosses the y-axis at what? Negative 3. So whenever you get y by itself, that's called what form? No, slope-intercept form. So y equals mx plus b is slope-intercept form. Slope-intercept form. So the coefficient of x is your slope, and the constant is where the graph does what? Crosses the y-axis, so your y-intercept. So the slope is not 2x, the slope is what? 2. On that worksheet some of you turned in, there are 4 of you that had 2x or 3x. The slope is the coefficient of x. It's just that number. All right, now, knowing that when you get y by itself, that's slope-intercept form, let's go ahead and try and graph this line. So write this number 1. Graph the line. Graph the line that has the following conditions. Okay, letter A. Suppose you're told that the slope is 3/7. Slope is 3/7. And that the y-intercept B is, let's say, -6. So you want to graph the line that has slope 3/7 and y-intercept -6. The other thing you got to remember about slope, though, see the slope formula, y2 minus y1 divided by x2 minus x1? You could also think of this and notice in the numerator, or your what coordinates? What coordinates in the numerator? The y's. And what coordinates in the denominator? X's. And which axis is the y-axis? The one that does what? The one that goes up and down. So the idea of rise. Which axes deal with the x coordinates? The horizontal. Okay, so run. So another way to think of slope is rise over run. Rise over run. So when we do this number 1 right here, we're going to use the idea of rise over run to help us graph this. So remember, slope is the change in y coordinates divided by the change in x coordinates, which means rise over run. All right, so take out that graph paper, not the big one, the one that's smaller.
Do you have a ruler?
Put it on that table.
Anybody else? Ruler? Anything?
All right, so in number 1, you're told that the slope is 3/7 and the y-intercept is -6. And what is it I want to do with number 1? I want to graph that line. All right, to graph a line, how many points do you need?
2.
2. Do I know anything about a point so far?
Y-intercept.
Yes, the y-intercept. That's a point of the graph where the point where the graph crosses the y-axis. So I know a point. How many do I need? 2. I need how many more? 1. So I'm going to go ahead and plot that y-intercept. So the y-intercept's -6, right? So that's right here. So there's my y-intercept. That's where the graph crosses the y-axis. And I'm going to use the slope. And remember, the slope here is, what did I say, 3/7, which is rise over run, correct? And so my rise means you go up or down. My run means you go right or left. In this case, my rise is what number? 3. But a positive 3, correct? So from your y-intercept, and you always start from the y-intercept, not the origin, the y-intercept. From that y-intercept, you're going to go up 3 units. Why am I going up 3 units?
That's your rise.
Because the rise is what, though?
3.
Positive. Positive. So I go up 3 units. So I'm going to say 1, 2, 3. Now don't put a dot there. You just hover over that grid. So 1, 2, 3. And then my run is what? 7, positive 7, which means I go which way? To the right. So 1, 2, 3, 4, 5, 6, 7. So there's the other point. Then you just take your ruler and you draw the line. So that is the line that has what slope? 3/7. And what intercept? -6. Okay? All right, so that's number 1. Number 2, let's suppose, or actually B, let's suppose this time that my slope is -2 fifths, and my y-intercept is, let's say, 8. So the slope is -2 fifths, and my y-intercept is 8. All right, to graph a line, how many points do you need? 2. Based on this information right here, do I know any point that's on that line? The y-intercept, which is what? 8. So I do the y-intercept first. I plot that point first. So my y-intercept is 8. I use the slope to find the other point. What's the slope in this case? -2 fifths. All right. So remember, rise over run. Rise over run. So let's put the negative with the numerator. It does not matter. You can put the negative with the denominator. And I'll show you that you're going to get the same line regardless. But we tend to put the negative with the numerator when we talk about rise over run. But it would not matter if you said 2 divided by -5. It does not matter. You'll still get the same line. You'll get a different point, but it'll be the same line. Because these lines have how many points on it? An infinite number. All right, to find the other point, do I start at the origin or do I start at the y-intercept? Start at the y-intercept. Okay, so I start at the y-intercept, and let's do the rise first. My rise is what here? -2. So that means I go up 2 or down 2? Down 2. Do I put a dot here? No. Then I do the run. The run is what here? +5. So that means I go which way? To the right 5. So 1, 2, 3, 4, 5. All right. I get that point. Now, if I had, just to show you, if I had said 2 divided by -5, I would get the same line. It would just be a different point. So I started these y-intercepts still. This time my rise is +2. So which way do I go? Up 2. 1, 2, right here. And then my run, though, is what number? -5. So go which way? To the left. 1, 2, 3, 4, 5. And notice that when I draw that line, it goes through all 3 points. So it does not matter where you put the negative. Okay? Now, the other thing I want you to notice as we go through this, see here the slope is positive or negative that I'm pointing to? Positive. What do you notice about the line as you go from left to right? It rises. As you go from, remember, you always read a graph from left to right. So as you go from left to right, your line is rising, meaning that the y values are doing what? Increasing. Here, my slope is what kind of number? Negative. We say that the line is falling, which means that the y values are getting what? Smaller. Okay? All right, now let's look at this one. C, suppose the slope is 3 and the y-intercept is negative 2. All right, the first two for students seem to be a little bit easier than the third one because when they see that slope as a fraction, they think rise over run. Hey, I can see a rise and I can see a run. But you got to remember that with whole numbers, you can also write as a fraction. How can you write 3? 3 divided by 1. And so when you graph that one, all right, so you graph that one. What do I plot first? The y-intercept, which is negative 2, okay? So this right here. And then I use the slope, and what's the slope? 3 divided by 1. So that means that the rise is 3, so that means I do what from the y-intercept? Up 3, 1, 2, 3, and then what? To the right 1. All right, and then notice that the slope was positive, so my line better be doing what? Rising, and it is. So as you go from left to right, your y values are increasing. God, there's a, I don't know what's wrong with this. There's a glare on that video. All right. Let's look at this one. D, suppose that the slope is 0 and the y-intercept is 4. Slope is 0 and the y-intercept is 4. All right, what's the y-intercept? 4. Remember, graph line, you need 2 points. Slope is 4. So 1, 2. I'm sorry, I said the slope. I meant the what? Y-intercept. Y-intercept is 4. All right, and let's talk about the slope. The slope is 0. Let's write it as a fraction. I can write 0 as what? 0 over 1. What else? 0 over 4, 0 over negative 6, right? You all agree? It does not matter what your denominator is as long as it's not what number, though? 0, because you cannot divide by 0. So I can write 0 as a fraction, just like I did 3. I can say 0 over 1, 0 over negative 3, 0 over 6, 0 over 8, 0 over 10, 0 over negative 2, and so on. Because all of those are equal to what? 0. On that worksheet you turned in yesterday, the slope of one of them was 0 over negative 8. You had to say what, though? You better not have said 0 over negative 8 is the slope. You better have said what instead? 0. So I'm going to use that idea here to find the other point. Okay, so here's what you do. So first of all, what do I plot first? The y-intercept, which is what? 4. All right, now, The rise is what number in all cases? 0. So let's think about the rise in the other. So if the rise was 3, that means I go up 3. If the rise was -2, that means I do what? Go down 2. If the rise is 3, I go up 3. All right, but in this case, the rise in all of them is what? 0. So that means, do I go up, down, or stay? I stay. I don't rise at all. So on this Y-intercept, I stay there. I don't go up, I don't go down, I stay. The rise is 0. Now let's talk about the run. Let's use 1. So from here, I go to the right what? 1. So there's my point. Or I could have chosen -3, which means I go which way? To the left 3. 1, 2, 3, and so on. Notice though, regardless of which of these denominators you use for your run, you're going to get what kind of line? Horizontal. So all horizontal lines have what slope? 0. So if you have a slope of 0, then that means you're dealing with what kind of line? Horizontal. Okay? All right, so a line that has positive slope rises. So that has positive slope right here. A line that has negative slope does what? Falls. Now, when I say fall, it's just like when we talked about increasing, decreasing constant. Your y values are doing what? Decreasing. That's what's happening. And then if your slope is 0, you have what kind of line? Horizontal. Okay. All right. Now, let's look at this. So remember a while ago we said that if we have y by itself, it's written in what form? What's that form called? Slope-intercept form. So y equals mx plus b. That's slope-intercept form. Right? But not all linear equations are written in slope-intercept form. So, for example, it could be written something like this. I'm going to kind of put number 1 and then I'll say some directions. So kind of leave some space here. So let's say I have this line, 3x plus y minus 4 equals 0. Is that written in slope-intercept form? No. Why is that not in slope-intercept form? Why it's not by itself? Now, when everything is on one side, when every term is on one side and 0 is on the other, that's called general form. So in my math lab, they're going to ask you something about general form. So general form of a linear equation, linear equation, I'll just say equation, is this. ax plus by plus c equals 0. So that's general form of a linear equation. So all the terms on one side, 0's on the other. So in my math lab, they're going to use the word general. Okay? So this number 1 you have here, that's in general form. And it didn't matter if you did not know that word anyway for what we're about to do, because I'm going to ask you to write this in slope-intercept form. So write each equation in slope-intercept form. But make sure you know the word general form from my math lab. Okay, so that one's pretty easy to do, because what do you notice about the coefficient of y? No, it's not by itself. It has coefficient of 1. That's what I want you to say. So then all I got to do is just bring every other term to the other side. So that means I'm going to do how do I bring that negative 4 to the other side? I do it to both sides. Add 4 to both sides, and then I add or subtract a 3x, or add a negative 3x to both sides. So let's do one at a time, though. So the first thing I'm going to do is add 4 to both sides, and so I get 3x plus y equal 4. And then I'm going to do what? Subtract 3x from both sides. And let's write it in y equals mx plus b form. So let's put the x term first. So when I combine like terms, I get y equals what? Negative 3x plus 4. All right, so that is slope-intercept form. So now you can tell me the slope. And what's the slope? What's m? Negative 3. And what's the y-intercept? 4. All right. So the directions will say something like write each in slope-intercept form and then indicate or state the slope and the y-intercept. State the slope and y-intercept. Okay, number 2, suppose we had this one. 2x minus 3y plus 9 equals 0. Now that one's going to be a little bit more challenging, and depending on your process, you just need to be a little bit careful. All right, so I got to get y by itself. So that's slope-intercept form. Y equals mx plus b. So you could, if you wanted to, bring the y to the other side, right? So in other words, I could do what to both sides? Add 3y to both sides. Okay, so I'm going to add 3y to both sides. And then combine like terms, I get 2x plus 9 equal 3y. Is that slope-intercept form? No, because I don't have y by itself. So what's the next step? Divide both sides by 3. So I'm going to go ahead and rewrite this over, which means this right here. Divide the left side by 3, divide the right side by 3. But don't leave the left side like this. You have to write it mx plus b. So meaning this, right? This is 2 separate fractions. Now, you all agree that 3 divided by 3 is 1, right? So this is y equal. So that's 2x divided by 3 plus 9 divided by what? 3. But you can simplify this. So your answer is going to be y equals 2/3 x plus what? Plus 3. Oops. So 2/3 x plus 3. So what's the slope? 2/3. Remember, the slope is a coefficient of x. What's the y-intercept? 3. So that's why the graph's going to cross the y-axis. Number 3. Oh, let me go ahead and do it this way as well, just to see what you would do. So this is number 2 again. I'm going to go ahead and rewrite it. Let's kind of do it like we did number 1, where we kept y on the left side and brought everything else to the other side. Let's see what happens. So I'm going to subtract 9 from both sides, right? And so I get 2x. When I combine like terms, I get 2x minus 3y equal negative 9. So someone could have done that. Then what's the next step? Subtract 2x from both sides and combine like terms, and I get negative 3y equals negative 2x minus 9, correct? Then what's the next step? Divide both sides by negative 3, just like this. Negative 3 divided by negative 3 is 1. 1 times y is y. And I'm going to write this as 2 separate fractions. So negative 2x divided by a, negative 3. Minus 9 divided by a, negative 3. But don't leave your answer like this, because you have to know that negative divided by negative is a positive. So you're going to say y equals a positive 2/3 x, and what's negative 9 divided by negative 3? Plus 3. All right, so either approach, you get the same slope-intercept form. All right, number 3, suppose you had this. Suppose you had negative 4x minus y equal 7. Now the first two are in general form, because that's where you had all the terms on one side, 0 on the other. This one's not in general form, because the 7 is already on the other side. But you still want to get this in slope-intercept form. What would be the quickest way to do this? Actually, there's either approach will be the same path. You want to add 4x to both sides? That's fine. So add 4x to both sides. Now the problem with doing that is this. Yeah, some of you are going to say y equals 4x plus 7. It's not y, it's what? Negative y. So you got to be careful. So negative y equals 4x plus 7. But then some of you still don't, you probably do, but you're not quite sure that the coefficient of y here is actually what number? Negative 1. So you may want to rewrite this as negative 1y equals 4x plus 7. But then you got to remember that if I want to write this in slope-intercept form, I've got to get 1y by itself, not negative 1y, 1y, right? So that means I got to divide both sides by what? Negative 1. Right? Divide by the coefficient. Now, don't divide by negative 1y. You never divide by a variable. You always divide by the coefficient. So notice in all these cases, I never divided by a variable. It was always a number. What's negative 1 divided by negative 1? 1 times y is? Y. Equal, what's 4x divided by negative 1?
Negative 4x.
What's positive 7 divided by negative 1? Negative 7. So what's your slope? Negative 4. What's the y-intercept? Negative 7. Not positive 7, negative 7. All right. Okay. So then the other thing you have to be able to do is graph a linear equation by finding intercepts. All right. So make sure you read the directions. Some of you still have a habit of not following directions. The directions are important. So if it says graph by finding intercepts and you graph it by using slope and y-intercept, you didn't follow directions. Okay? Follow directions. All right, so let's remember something about intercepts. There are two intercepts, and we talked about these in previous worksheets, previous lessons. There are how many? There are what kind of intercepts? X-intercept and y-intercept. The x-intercept, remember, is where the graph does what? Crosses or touches the I said x-intercept, right? So it crosses or touches the x-axis. The y-intercept is where the graph crosses the y-axis. All right. So when that happens, and if you go back to the worksheets where you have to list the intercepts, no matter where I am on the x-axis, these are all x-intercepts, what is the y value in each of these cases? 0. The y values are zeros in all these cases. If I look at the y-intercept instead, if I look at where the graph crosses the y-axis, if I look at all these y-intercepts, what can you tell me about the x-coordinate in each of these cases? The x-coordinate is 0 instead. So the x-coordinate is 0. So the idea is this. If you want to find, so if you're given an equation, of a line, and you want to A, find the y-intercept, then all you do is let x equal 0. We just talked about the fact that when the graph crosses the y-axis, what is the x-coordinate? 0 in all cases. So if you want to find the y-intercept, you let x equal 0. If you want to find the x-intercept, so you got to think about the x-axis. So for the x-intercept, what is the y-coordinate? 0. So you're going to let y equal 0. All right. Now, let's get at this problem. So we're going to graph, number 1, we're going to graph each linear equation by using intercepts. So we're going to graph each linear equation by using intercepts. All right, here's the first one. A, suppose I have this linear equation, 2x minus 5y plus 10 equals 0. What form is this in, this equation? General form. So that's where all the terms on one side, zeros on the other. So you need to know that word from math lab. All right, so let's find the x-intercept first. If I want to find the x-intercept, you're going to let y equals 0. So the term that has y in it actually becomes what? 0. Because let's think about this. If I'm saying y is 0, then what's negative 5 times 0? 0. So if you let y equal 0, then basically all you got to think about is, well, this term then is 0. So then what equation do you see you have left? 2x plus 10 equal 0. That's what you have left. And then all you do is solve for x. So how do you get x by itself? Subtract 10 from both sides. I get 2x equal negative 10. Divide by 2. And I found the x-intercept. The x-intercept is what number? Negative 5. So that's where the graph's going to cross the x-axis. So then you plot that. So take that grid paper out. So the x-intercept negative 5, that's here. So that's where the graph's going to cross the x-axis. Now I've got to find the what? The y-intercept. To find the y-intercept, what do? Let x equal 0. So this time, if I look at the term that has x in it, that's like 2x. If x is 0, what's 2 times 0? 0. So cover that term, that 2x term, because you know that's going to be 0, and then look at what equation is left. What equation is left? Negative 5y plus 10 equals 0. And then all you do is solve for y, and you found your y-intercept. So what's the next step? Subtract 10 from both sides. And so I get negative 5y equal negative 10. Then do what? Divide both sides by negative 5. And I get y-intercept is what? 2. So then I plot 2 on the y-axis. So that's here. And I draw my line. And so notice that I'm drawing a graph in which I found the y-intercept and the x-intercept. Now, if you're asked to write these intercepts as an ordered pair, x-intercept as an ordered pair, there are a couple of you that still don't understand what an ordered pair is. An ordered pair is a point. You have to use parentheses to denote a point. So this is my x-intercept. What is that point right here? Is it 0, negative 5, or negative 5, 0? Negative 5, 0. Your y-intercept as an ordered pair is what? 0, 2. Okay, not 2, 0, 0, 2. Because remember, to plot a point, you always start the origin, right? So if I start the origin and I go to this point right here, that means I don't go right or left at all. So that means that my x-coordinate's what? 0. But then I go straight up, and what's my y-coordinate? 2. For this one, I start the origin. I go which way? To the left 5, so hence negative 5. But I stay there. So that means I don't go up or down. So that means I stay there. So what's y? Y 0. All right, let's look at the next one. Okay, B. Let's suppose I had this. All right, suppose I had this equation. 6x plus 4y minus 12 equal 0. 6x plus 4y minus 12 equals 0. And again, you want to make sure you follow the directions. The directions said do not graph this by using slope and y-intercept. It said to do it by which way? Finding intercepts. So that's where you got to say let x be 0, let y be 0. So to find the x-intercept, what variable is 0? Y. So you let y equals 0. So if y is 0, that means 4 times y, 4 times 0 is 0. So that term you can cover up, and then what equation do you see left? 6x minus 12 equals 0, right? And then you solve for x. So you add 12 to both sides. So I get 6x equal 12. What's the next step? Divide by 6, and you found your x-intercept, which is what? 2. So then I plot that point. So I'm going to put a point on the x-axis at 2. So right here. So there's my x-intercept. That's where the line's going to cross the x-axis. All right, to find the y-intercept, you're going to let x equals 0. So if x is 0, that means 6 times 0 is what? 0. So that term goes away. So cover it up. What equation is left? 4y minus 12 equal 0. And then you solve for y. So add 12 to both sides. I get 4y equal 12. What's the next step? Divide both sides by 4, and I found the y-intercept. The y-intercept is 3. So that's where the graph's going to cross which axis? The y-axis. So it's going to cross the y-axis at positive 3. And so then I draw the line. And I get this. Now, you may be told to write the intercepts as an ordered pair. So if you're told to write as an ordered pair, you would say this. The x-intercept, blank, what's the point? 2, 0. The y-intercept is what point? 0, 3. All right. Okay? All right. A couple more things. There's some there's a couple of special cases in terms of graphing lines. So far you know this. You know that this line right here would have what kind of slope? What kind of slope? Positive. Its slope is positive. This line right here would have what slope? Negative, because the line is falling, right? All right. And notice that when you go back to the beginning of class where we had those equations, you had an x and a what? A y. So if you have an x and a y, your line's going to rise, or it's going to do what? Fall. But not all linear equations have an x and a y explicitly there. So for example, I could ask you to graph this. F of x equal 3. So graph f of x equal 3. Now notice I'm using function notation. I'm using function notation here because that graph is going to be a function. That's a function that we're about to graph. And you notice it's going to pass what test? Vertical line test. But remember also that f of x can also stand for what letter? Y. So f of x equal 3 means the same thing as what equation? Y equals 3. And so if I use a t-table, notice there's no x there, right? You see an x? No, all you see is a y. So students get a little hung up when there's no y there. But we talked about that in a previous class. So if y is 3, that means that y always equals what? 3. So down this column, y is always going to be what? 3. No matter what x is. So if x is 4, what's y? If x is -1, what's y? If x is 0, what's y? That's what that says. That said y has to equal what? 3. There's no x there, so it doesn't matter what you put in for x. Y always equals 3. So when I plot those points, you're going to notice that you have what line? A horizontal line. So 4, 3 is here. -1, 3 is here. And so when I graph the line, it is horizontal. Okay? So what should the slope of this line be then? 0. The slope should be 0 because all horizontal lines have what slope? 0. Slope is going to be 0. Now, let's go back to that equation we had here, y equals 3. There's a y there, right? And y is by itself, isn't it? So technically, I can write it in slope-intercept form because there's a y there. Now you may say, well, how could you? There's no x. Someone said it. 0x. I can write this as y equals 0 times x plus 3, couldn't I? Because what's 0 times x? 0. What's 0 plus 3? 3. What's the coefficient of x? 0. So if y is by itself, then the coefficient of x is the slope. And what's the slope here? 0. Now, you saw this equation right here where we had y but no x? You can have x and what? No y. Now, when I grabbed this, you saw that this was a function, right? How do you know that this is a function? It passes the vertical line test. When I do this one, x equal, let's say, 7, I cannot use function notation here. In all the ones we did, if you go back to all the ones we did where we got y by itself, I could have used function notation because those were functions. But I can't use function notation here. On one of your worksheets, when we do this, then you're going to have to recall on one of the worksheets there was something about that. One of the worksheets when we talked about functions back then. So I'm going to do a t-table just like I did this. Now when I did this one, remember that said that y always equals what here? 3. So in the y column, all you saw was what number? 3. You didn't see any other number. So when I do this one, this says that x always equals what? 7. So down the x column, I'm going to have all 7s, no matter what y is. So if x is 7, y could be what? 0, 2, 1, -1, and so on, right? Any real number. There are an infinite number of points you could put here. Now when I plot 2 of those points, though, 7, 0, and 7, 2, what kind of line do I get in this case? A vertical line. I get a vertical line. Now, one of the worksheets, you saw that a vertical line is or is not a function. It's not a function. It fails a vertical line test. So that's why we could rise a function. That's why we could not say f of x equal something. All right, so x equal a number is a vertical line. Y equal a number is what kind of line? Horizontal. Now we saw here that the slope was 0, right? For the horizontal. Let's kind of determine what the slope of a vertical line is. So let's use 2 points to use the slope formula. Let's say I want to use this point 7, 2, and let's use this one right here, 7, -3, okay? So I'm going to use those 2 points to determine the slope. So if this is x1, y1, then this has to be what? x2, y2. And what's the slope formula?
Y2 minus Y1.
Over x2 minus x1. That's on your test. Slope formula is on your test. So what is y2? -3. Subtract y1, which is 2. What's x2? Subtract x1, which is what? 7. What's the numerator? -5. What's the denominator? What's -5 divided by 0? Oh, no, it's not. It's undefined.
Divide by 0.
You cannot divide by 0, right? Put that in your calculator. -5 divided by 0, you get undefined, you get an error, you get
Divide by 0.
whatever your calculator shows you. That's undefined. Not 0. It would be 0 if 0 is located where? In the numerator. 0 divided by -5 is 0. 0 divided by 6 is 0. But you can never divide by 0, so that's undefined. So the slope is undefined. That was one of the worksheets you had to turn in today, wasn't it? Or yesterday? There were 4 questions that asked you something, and the answers are either 0 or undefined. So all vertical lines have what kind of slope? Undefined slope. All horizontal lines have what kind of slope? 0 slope. All right, so that takes care of this part. All right.